Hi, my name is Mikkel, and in this example we are moving from the university sandpit into the real world of a screw pile project. In this project we are in Copenhagen, installing at CPH Village, where we are building some temporary student houses. So in this case we can't control the soil profile, we can't control the advancement ratio or the speed as precisely as we could in the laboratory. So we are influenced by how well the installer actually installed the piles. The only thing we can control is the pile geometry, since we can decide which pile to install. The clay that we are installing the piles in has an undrained shear strength of around 300 kilopascals. Pile 1 has a diameter of 76 mm and a thread of T12. It was installed with an advancement ratio of around 0.9, which is a pretty good installation, and a speed of around 12 RPMs. It measured a torque of around 2,200 Newton meters during the last rotation. Pile 2, same pile type, a little worse installed with an advancement ratio of 0.89 and a speed of 11.8 RPM. It measured approximately 2,300 Newton meters during the last rotation. And then we had pile 3, same pile type, the best installed pile with an advancement ratio of 0.98 and a speed of around 13 RPMs. It measured a torque of around 2,400 Newton meters during the last rotation. Then we have the last pile, pile 4, same pile type, and was installed with an advancement ratio of 0.96 and a speed of 12 RPM. It measured a torque of around 6,300 Newton meters during the last rotation. And when you look at those installation torques, you will instinctively think that the last one has a really good bearing capacity because it had the much higher torque readings. But in reality, when we look at the static load test, we can see that piles 1 to 3 actually had a bearing capacity from 98 to 111 kilonewtons. Whereas pile 4, which has a torque that was almost 3 times bigger than what we measured in piles 1 to 3, its bearing capacity was only 76 kilonewtons. The reason was that it was installed in sand, which gives much higher torque readings during installation than clay, but has a much lower bearing capacity. So from real data, we can easily see that you can't just rely on torque to determine bearing capacity. It really depends, again, on the other examples, what pile type it is, how fast you have installed it, what the advancement ratio is, and now also what you are installing it in. So the soil profile is very important. So you have to know all of these things before you can predict the bearing capacity of a screw pile you haven't tested. I hope you found this information useful and that it provided insights into the importance of correctly monitoring and documenting a screw pile project. Follow for more information, where we will look into other examples and important areas when using screw piles in your project.